In this video, we'll be talking in a little bit more detail about the data types available in SQLite specifically. So to start off with, here's kind of a tricky question. In SQLite, is 1 the same thing as 1.0? And in reality, you can't really know from the outset, but I'm going to tell you that the answer is yes, question mark. Now why is that? Because SQLite tries to be really smart. And a lot of the times, what it does is for small floating point values, you can read the text if you want, for small floating point values, and if they don't have a fractional component, they'll actually just be stored as integers to save space, and then converted back to floating points when you have to actually write them out. So SQLite can do tricky things under the table with your data, but you would never know. You would say, hey, I'm trying to store 1.0 in this real column, and then when you ask for what is the value that I just gave you, it would give you 1.0. So how databases work under the table, under the hood, may be different from what you might expect, but in reality it doesn't matter as long as the database is telling you the things that you expect. As long as it's guaranteeing its kind of promises to you as to if you give it a floating point, it'll return back to you a floating point. But just keep that in your mind as we're working through these things about the difference between the kind of the API, how you use the database, and actually what the database might be doing underneath the covers in order to make things happen. Okay, so let's start with talking in a little bit more detail about these data types. Easiest one to talk about is null. Null is a value that you can really stick in any column, even if you specify, hey, this is an integer column, you can have all the integers you want and you're allowed to have null. It normally represents the absence of information or an inapplicable value, like an NA value. However, some people use null to mean some other things, like to mean nothing or empty or false or zero. These are really bad uses for null. In reality, if you need to represent nothing, you probably want to use the empty string. If you want to represent false, you probably should represent the string false or the number 0 or some other clear notation saying there is true, there is false, and there's possibly also null. And if you want to represent 0, just use a 0. Okay, so how do you use null? Well, so let's say, for example, we want to have a table about state. We want to have the state's name and the year that they were admitted to the union. You would have Michigan and whatever year Michigan was admitted to the union. But if we wanted to add Puerto Rico to this table, well, it has a name, but it doesn't have a year it was admitted to the union. We shouldn't put a 0 or a -1. What we should stick here is null, because there's not a value that makes sense to stick here other than to say, this doesn't really make sense to put anything here. Next, we're going to talk about integer. How does integer work? Well, it's a signed integer up to 8 bytes long, which is 64 bits. So what range is that? It's a big range. You don't need to memorize this number. You can if you want. So what's an example of an integer? 1. All right. You could also have negative numbers there. Commas aren't allowed. You guys have seen integers before. I hope that's nothing new. Okay. The next type are real values, which are 64-bit floating point values. I'm not going to write out the range of 64-bit floating point values. You can look them up if you want. You can specify them as either decimal like 1.0 or an exponential notation using the capital E. So here are some examples. These are all real values. The next big type to talk about is text, or really strings. So the text can be of any length, but it must be enclosed in single quotes. We've talked about this before. Single quotes inside your string must be escaped with a single quote. So here's an example of the empty string, or here's an example of a string with an escaped single quote within it. Many databases give you access to a particular fixed length text, like say I want to have a column that has strings up to 32 characters long, or up to 100 characters long, up to 1,000 characters long. However, the nice thing is we're working with the best database management system, which strings don't have any arbitrary upper limit bound. So first multiple choice question, what is the best database management software? Now, this is a little bit of a silly question. Once again, the database management software that we're spending almost all of our time talking about is SQLite specifically, and we'll be talking about the other database management software when principles specific to those matter. Okay? So you might be going, okay, I have null, I have integer, I have real, I have text. Well, what other sorts of things would I want to store in a database? Well, another sort of thing you might want to store are dates and times. And SQLite, and actually most databases, don't have necessarily a very specific data format for handling dates and times. Usually, dates and times are encoded in one of these other formats. For instance, as text, as these sort of strings, let's say year, month, day, hour, minute, second, fraction of a second. Or real as Julian day numbers, like number of days or number of seconds. Or integers, which is the number of seconds example since the beginning of time, which was 1970, January 1st. We'll be talking a lot more about dates and times later on in the class. If you want, you can go to this link for more information. Okay, one other important data type is that of BLOB. So BLOB is used as to hold basically binary data, so often images or video or other non-textual data. There's no storage limit like text. You can have it as large as you want. How would you specify a blob? Well, you would specify it with this sort of notation with the capital X and then single quotes and then a hexadecimal string of characters. However, blobs aren't really ever used in those like insert into statements. They're often used in parameterized queries, something we'll talk about later. So in general, if you're writing queries, you tend not to be working with the blob data type. And in reality, we'll be avoiding them in this class, mostly for simplicity. They're often used to hold objects or kind of raw data. That's kind of beyond the scope of this class. Of course, my favorite version of the blob is that from, X-Men Evolution, but the blob data type is primarily used to hold arbitrary binary data. Okay. And to be entirely complete, there's one other data type that SQLite supports. It's called numeric. All right. There's a big block of text here that basically says numeric is one of the other types. It's either text or integer or real. And it's stored in one of those three forms as long as there is some lossless way to convert it. So you can specify a million-digit number, but a million-digit number won't fit in an integer or real, but it can be stored as text. Or you could say, hey, this type is numeric, and you store a number 10, and the new SQLite is smart enough to go, oh, 10 is something that will fit in an integer. I'm going to store the number 10 as an integer. It's a way to basically have a column type that doesn't have limits, that has arbitrary precision. In reality, once again, this is something that we're not going to be using in this class, but if you really care about specifying to a very precise number or very large numbers, you would use the numeric type. Other databases also supply some other data types. For instance, a memo data type holds a fixed number of characters. That's common in some of the other database systems. There's often a currency data type, which has 15 whole digits and 4 decimal places in base 10 for if you want to be really careful not to avoid floating point rounding errors and things like that. Microsoft Office has this yes-no data type. There's often enums, which are basically, you can specify strings, but they have to be within this small set. In reality, you can emulate all of these other data types in SQLite, often using text, integers. And you can write functions to convert between these forms into a form that SQLite can store, and then you can write functions that will convert the SQLite stored version into one of these data types for export purposes. But once again, these are things that we won't really be covering in this class because they don't really add much of anything interesting to the class.